So now we're going to dig into strings a bit, and we've already looked at how you can pull out a single character in a string, and now we're going to look at what we call slicing, and that is pulling chunks of a string out. And again, we're going to use the square bracket operator, and so S, and the way I say it is sub, S sub 0 through 4. That's how I read this. S sub 0 through 4. So I look at the colon as through, I look at the brackets as sub. And so S sub 0 through 4 says start at position 0 and then go up through, but not including 4, right? So we don't include 4. So that's probably the hardest part of this. Up to, but not including. Up to, but not including. This seems counterintuitive, kind of like starting at 0 seems counterintuitive, but after a while, you get used to it, and there'll be situations where you're writing code like, oh, that's why that works better. But just for now, remember it. Up to, but not including. It's just kind of a little thing. We'll come back to when that is useful for us. 6 through 7, well, that ends up being starting at 6, up to, but not including 7. So that's why we only get the P out. Now, one thing that Python is pretty nice about is it's not going to give you a traceback. We might expect that 6 through 20, well, there's no 20 characters, but it's like, that's okay. We'll just let you stop at the end, and we'll start at 6 and go all the way to the end. Oh, no traceback. It's almost disappointing sometimes when Python doesn't trace back, when you think, if you're so obsessed about everything, I would have traced back in that situation. But hey, I guess if you're allowed, you're allowed. And so there we go. Now you can eliminate or omit the first or last. If you eliminate the first, it assumes the beginning of string. If you eliminate the second, it assumes the end of the string. And why you would do this, I don't know, but that's from beginning to end, so it's the whole string. So whole string, 8 through the end is thon, and up to but not including 2 is mo. All right, so you get that. So that's pretty simple. Once you've got the rest of slicing and the rest of string indexing, the notion of eliminating the first or the last of the colon expression, the first or second of the colon expression, I think is actually pretty intuitive, pretty nice. We've already been concatenating strings together. We overload the plus operator, and there is no space added. Remember, when you're doing print, x comma y, this comma does turn into a space, but that's not what's happening here. There is no automatic space being added, and so we see hello in there, and it just is hello there with no space. And so if we want, we just have to concatenate the space explicitly if we want to put spaces into strings. The problem is if this, you might think it's more convenient to add a space with a concatenation, but then you have to think, well, what about if I want to concatenate things and not put the space in? Then I'd need a different operator. So that's kind of why it works that way. We can use in differently as a logical operator, so we're using it as an iteration structure in for loops, but we can also use it as a logical operator in if statements. So it's kind of like the double equals or not equals or less than or equals or something like that. It's like those guys, and it returns a true or a false. Is n in fruit? So that's a question, and the answer is true. Is m in fruit? No, that's the answer to a question. Is nan in fruit? Doesn't have to be single character, can be more than one character, and the answer is true. And then you say something like, if a in fruit. And so this is the logical value that returns a true or a false, and yes, we found it. So that becomes true in this particular case, so it runs the little indented bit. So in is an operator in this particular situation. In a for loop, in means something different. And we'll use in for other things as operators, as logical operators coming up in a bit. You can compare strings, and this has to do with the character set of your computer, the character set that Python is, but in general, it is lexicographically less than and lexicographically greater than. Uppercase and lowercase are a little weird. I think when we used the max function earlier, the way my computer was set up, uppercase was less than lowercase. But in general, uppercase is less than lowercase. But in general, it's bad to assume case, but there is a deterministic way to sort strings. You can, have something equal to or less than or greater than, and all those operations work naturally. The less than and greater than, you have to kind of be aware of uppercase, lowercase, things like where punctuation sorts less than or greater than letters. That's kind of unpredictable and depends on the character set of your computer, and something you just play with and figure out. If you're doing sorting stuff by first name and last name, as long as the case is kind of the same, if you were sorting Chuck with an uppercase and Glenn, the fact that these uppercases, they'd sort right and these lowercases would sort right, but if you were to subdue instead lowercase Chuck and uppercase Glenn, then that would sort weird. As a matter of fact, the G would come before that. And so case can mess this up. But in general, other than case and special characters and other things, it technically works. It's just hard to kind of predict it. A lot of what we do is use the string library. And so the strings are objects, and we'll talk later about what that really means. And objects have these things we call methods. So a string object has some built-in capabilities, and one of the built-in capabilities that the string object has is, here is a string object, and because greet is a string object, if we said type, we'd see that it was an str. Dot lower says, hey, dear string, make a lowercase version of yourself. It's like calling this function lower and passing greet into it, and then give that back to me. Now, it doesn't actually change greet. It gives me a lowercase copy. So here I have hello Bob with an H and a B uppercase, and what I get back in Zap is hello Bob all lowercase. And note that greet is unchanged. So hello Bob is still there. And you can even call these methods on constants. So this is a string object, quote, hi there, quote, dot lower. That says, call lower on this bit of string and give me back a lowercase version of it. And so it prints out as the residual return value. This is like a function call. A method call is a kind of special form of a function call. It's a function call where you say the thing dot the function name rather than function name passed in as a parameter. Like len, for example, is non-object oriented. Len of x, that's non-object oriented. Object oriented would be x dot something, parenthesis. But, so constants are objects as well, and taking the lower gives us back lowercase hi there. And so that's just one of the things that you can do in the string library. These are built into string variables and constants. They're just always there. As soon as you make a string, they're part of it. And when you do type and it says it's class str, we'll get to object oriented. Don't worry, we'll get to object oriented. Okay, and so you can do things like use the type. If you're just, look, this used to say typester, but it's classter. Kind of, this is more of an the word class is an object-oriented concept, but it is a string, and you can use the dir, and of course there's extra stuff up here, and this is showing all the different methods or capabilities, things we can do to strings. So, x dot something, parenthesis. Well, what can we do there? This is all of those things that we can do to x's that are built in and come with x's, come with strings when we build them. And Python, of course, has great documentation online for all of these string methods and what they do and how they work and why they work the way they do. And so here's some of that Python documentation. We'll look at a few of these, but don't hesitate to say Python string uppercase, and then we're like, oh yeah, that is upper, right? And so here's a few things that we can do and use. Some of the ones I use a lot, and we'll look at each one of these things. So the find operation says find me a substring within a string. Right, find me a substring within a string, so find me the first NA and give me back the position. So that gives me back 2. And then I can say, go find a Z in there. Well, there's no Z, and so it returns me -1. So that's what the find does. So we're going to use this kind of stuff a lot, and we do a lot of looking in strings. Converting things to upper or lower case, there is an upper method and a lower method. So greet.upper, and that means the uppercase NNN is hello Bob. Greet.lower, that means that www is the lowercase hello world. And greet is unchanged. Greet is still hello Bob with upper and lower, because each of these methods basically say, I'm going to give you back a uppercase copy or a lowercase copy of the original thing without changing the original thing. Search and replace is super useful, super duper useful. And it's pretty clean. Here we have a string and we use the replace method. In this case, we're passing in the old and the new. Bob, replace all Bobs with Janes. And so that takes this hello Bob and turns it to hello Jane. Again, greet is unchanged. Greet is unchanged. And it does more than one thing. So this says go find, well, let's clear that. This says go find all the O's and replace all the O's with X's. And so it goes and finds 2 of them, and then out come 2 X's. And so that really is replace is not just replace the first one, but replace all of them. White space, as we'll see, is a big deal. And white space is not just blanks, although the most common thing, but it's also sort of non-printing characters like tabs and new lines and other kinds of things. And so we have a number of different ways to strip white space. So here we've got some spaces at the beginning and spaces at the end. And we do an L strip, and that throws away the spaces at the beginning. That's the left, so that's a left strip. It all takes any, if there's nothing there, it doesn't harm it. R strip means throw away all the blanks on the far end. And then strip says go take both sides for strip, and so that pulls out all the spaces on both sides. This will be useful because sometimes when you're tearing stuff apart, you'll find yourself getting extra spaces, sometimes at the beginning, sometimes at the end. And it can be tab or new line. It's sort of white space that is kind of not visible, clear. That's what white space is. It's like if you were on a piece of paper, it's the white space. It's like X. Well, that's not white space, but right here, oh, that's white space. It's any character that doesn't cause printing to happen, if that makes any sense. It's any character where nothing would be printed. And there are characters like that. There's like even bell characters, but we don't use them very much. We can ask very conveniently, we can say, hey, does this line start with a particular string? And so, you know, line, does this is a question, going to return a true or a false. Does this line start with please? And the answer is true, it does start with please. Does this line start with a lowercase p? No, it does not. And so again, you use this in the context of if something, colon, some block of text, some block of code. So we can combine these things to tear stuff out. And so let's assume that what we want to do in this case is we want to take a from line. This is from an email format from a mailbox. And this has got the from with a space and the person's email, and then @ sign in the school they're from, and a space, and then the rest of the stuff like when this mail was sent. And this is a real mail message from this guy, Stephen, from the University of Cape Town in South Africa. And it's really Stephen, and this really is the first line of a file that you'll get to know pretty well by the rest of this course. Hi, Stephen. We like you. You are the example in my class and have been for a long time. People actually who know Stephen have taken this class, and they're like, Stephen, I saw your picture in the class. So if you're ever in Cape Town at the University of Cape Town, say hi to Stephen and tell him that you saw him in the class. But okay, that's neither here nor there. What I really want to do is I want to extract his school from this email line. Okay, so now eventually we will do things like the data will come from files, but this is still chapter 6. So this is the data we're going to search through. And so we can say, hey, let's go find the @ sign. Search up to this position and find the @ sign. So data.find @ sign. And give me back where that's at. That's in position 21. This is position 0. Then what we're going to do is we're going to look for the next space after the @ sign. So we're going to start at the @ sign and tell find to start here and look forward until it finds a space. So data.find, look for a space starting at the position of the @ sign, and then that'll be in position 31. So 31 is what we get in the space position. So now what we have is we have in two variables, we have position, the position of the @ sign and the position of the space after the @ sign. Now what we really want is this bit right here. So we have to go one beyond the @ sign, and we don't want the space. So we say, we're going to use slicing here, data sub at position +1 up to but not including the space. Oh, smiley face, because we didn't have to say space -1 because that is up to but not including. And so we get that little bit right there. So we don't have to say -1 there, because this is not actually included. The thing that's at the position of the space is not included. So that's already a little benefit for the up to but not including. And so when we print this variable out, host, we get exactly just the school that Stephen works at and probably went to, as a matter of fact. I don't know if he went there or not. So this is just kind of a note for non-Latin character sets. All programming languages from the 60s on tended to work in what we call the Latin character set, which is the United States and England and Europe, and lots of places use this ABC character set and the special characters. But it's really common to want to use different characters. And so if you're going from Python 2 to Python 3, and we'll talk about this a little later when it matters more. Luckily, we're in Python 3, and so one of the big things about Python 3 is that all the internal strings are Unicode. In Python 2, there was sort of some confusion as you went between strings, and this is just a little bit of code. And so I'm putting in here, some Asian characters. This is Korean, actually. Asian characters into X, and then I say what kind of a thing this is, and that is a string. And then there's this Unicode, and this comes from Python 2. If it's a Unicode operation, it's still a string. Whereas in Python 2, if you put international characters into X, then it was a string, and then there was a separate kind of a constant called a Unicode constant, and it was a different type. And there was ways that you had to mess with these Unicode variables as you did things like read them from files and put them back into files and did other things. So it was much more difficult in Python 2, but we're doing in Python 3, and in Python 3 it natively understands non-Latin character sets, international Asian character sets, Spanish, French character sets. And so this is a good thing for Python 3, and this is one of the real benefits of using Python 3. And as we start doing stuff where we're exchanging data with the outside world, this will come into play, and I'll have to show you how to use it. There was weird things that you had to do. It just makes a lot more sense in Python 3. Okay? So we've talked about strings. We learned about the string. We're converting it. We've done a whole bunch of stuff, and this is, again, we're not yet doing anything super useful. We're learning sort of how to like slice and dice, even though we're sort of not making the meal yet. Up next, we're going to talk about files. We're going to read some data, and we're going to slice and dice and use all the things in the next chapter that we've learned up to this point. So see you in a bit.